Okay, so once again, if you have 2 points in the coordinate plane, you know the coordinates x1, y1 and x2, y2, we can work out the distance between them, and we do so by using Pythagoras' theorem. So let me very quickly remind you of Pythagoras' theorem. It says in a right angle triangle that the sum of the square of the sides making up the right angle equals the square of the hypotenuse. So a squared plus b squared is equal to c squared. That's Pythagoras' theorem. So if I let point A, if I slide this up a little bit, point A have coordinates x1, y1, and I let point B have coordinates x2, y2, then the length of side A here, if I call that side A, well, I know the length from 0 to there is y2. I know the length from 0 to there is y1 because that's the y coordinate of A. So this will be y2 minus y1. Excuse me. That will be the length of side A. Likewise, I know from 0 to there is x2 because that's the coordinate of x2. The x-coordinate of A is x1, so the distance from there to there is x1. So that minus that gives me that distance there. So x2 minus x1 is the length of side B. And so using our Pythagoras theorem, I can say a squared plus b squared, or in this case b squared plus a squared, x2 minus x1 squared plus y2 minus y1 squared will equal the distance that we're actually after, which is there, d. So d is the square root of that. So that just comes from Pythagoras' theorem. And so I guess what we can do with that is we could add that over here and have, look, here's the distance formula. That's something else that we know when we have the coordinates of 2 points in the plane. Okay? So it's just another formula to add over here. Distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 all squared. And that now is a nice little summary of what we know. And here's an example. We should do it, I guess. I might leave that page up, actually, I think. So I've got 2 points, minus 3, 5, and 5, minus 3. It won't matter which one you call x1, y1, which one you call x2, y2, because I'm squaring the thing anyway. So whatever negative signs are introduced will disappear anyway. So I shall call that one x1, y1, and that one x2 and y2. And then according to my formula, the distance will be the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So 5 minus 3 is 8. So that's 8 squared. Minus 3 minus 5 is minus 8 all squared. And of course minus 8 all squared is the same as 8 squared. So here I might write that as 2 times 8 squared. I mean, I could have worked that out, said 64 plus 64, that's 128. So this is the square root of 128. But if I do it this way, I can see that's the square root of 2 times the square root of 8 squared, which of course is just 8 root 2. So I didn't have to do any mental arithmetic there to come out with a simple answer. And that, of course, is the exact distance. If you were to get out a ruler and measure that, you would get an approximation to that, but you wouldn't get that exact value. Okay, so to use the distance formula, it's just a matter of straight substituting into the formula and evaluating your result. Nothing more to it than that.